So, all right. Welcome to the, final and concluding real lecture of the course. We have some information first to make it clear for everyone. On Friday, you have the first opportunity to take the online exam, and it's sometime between 0800 and the test will end at 5 p.m. So don't start the test too close to that deadline, because when that deadline has passed, well, the test will shut down. So at the latest start at 4 o'clock p.m. Then you at least have 1 hour. And the time for the actual test will be under 1 hour, but you probably need time to make comments and stuff like that. So don't start the test too late, so that you can at least have the opportunity to comment your questions. And if you miss this opportunity, the next opportunity is 1 week away. So Friday the 23rd, same time. And the last opportunity to pass the online exam is at the 29th. It's a Thursday. So and the times are also a little bit skewed there. So we have from 10 o'clock to 19. And you need to pass this individual exam, because otherwise you will get an F in the course. And if you pass the exam, you can just plug in your values for the workshops, and you will find your final grade here. So that is the basically what will happen with the exam. So we have a deadline approaching also. Tomorrow at 12 o'clock, lunchtime. Hand in your final workshops for workshop number 2. So we can take a look at them as soon as possible, and hopefully you will have the passing grade for workshop 2 also. Shouldn't be any questions, it's just like workshop 1. And next week we have the 3rd and final workshop. So if you have already done this, hand it in, start working on workshop number 3. In this workshop you will be continuing the blackjack game. So while the implementation you get is not 100% as the one we have developed during the lectures, it's always a little bit different from year to year. So basically it's the same ideas there. And you can get C# code or Java code. If you want something else, well, then you need to translate it yourselves to begin with. So, well, basically it's the same thing. You have a couple of requirements. In this workshop we focus on some refactoring and some design mainly. You should be able to use some design patterns to extend the functionality in this game, and basically you should provide a source code for the entire application and an updated class diagram. So when you have done your changes, you make a new class diagram for this. And we have some more requirements for grade 3 and for grade 4. So I hope that will also run smoothly. And if we look at the deadlines again, the deadlines for workshop 3, the final hand-in, is at the end of the course. And this is also where you can hand in your higher grades for the workshops. So you will be getting a couple of forms there to fill in if you have the ambition to hand in for higher grades in the workshops. If you miss any of the workshops, or don't pass them and don't have the opportunity to make a fix, you need to do the Yahtzee game. And this you do in its entirety. It's quite a big task. And if you think you need to do this, you can contact me and we will discuss a deadline for you. And this can be some weeks into the next study period if necessary, but I don't think we should drag it along for too long. So try to finish this off if you need to also before you forget too much. So that being said, today is time to repeat what we have been saying during the course. Maybe focus on some specific issues that you have. And I got one issue regarding the problems of identifying associations and dependencies and different kinds of relationships in code and make them into a class diagram. So we have some example questions here. This is from 2013 and they are not at all the same this year because now we will have a multi-choice test instead. But these can be good for you to make some exercises. And also on the 2014 course homepage, we took a couple of them and showed how they could be solved. So you can always go to this old page and take a look at these. But we will be doing one of these today, and basically they are in a couple of tasks where you are supposed to construct the correct UML class and sequence diagram giving the following pseudocode. So we have some code here in some kind of language that, well, it's not Java and it's not something else, but you should be able to recognize it, I think. And we have 3 of those, I think. So maybe we should just do one of these today and take a look at it. 4 maybe even. And we also have some design problems where you get some code and there is a problem in the code and, well, you should solve this. But anyway, we will take a look at that later today. Is there anything else that you think have been problematic during the course or hard? Something that we should focus on today? Or should we just make a generic run-through of everything? The grasp patterns? Yeah. Yeah, they are kind of fundamental, so it could be a good idea to repeat them thoroughly at least once more. Is there some certain principle among these patterns that you think are problematic? No? All of them? Anything online in Connect? Yeah. Okay. So, but we will make a run through of the entirety of the course, and we will stop and focus on some interesting aspects. And of course, you are free to ask questions and such during this time also, of course. And for the next 2 lectures, tomorrow and on Friday, if I am not mistaken, we will have a questions and answers session, but we will do these online only in Connect. So I will be available to answer questions you have. And also those sessions won't be recorded, so feel free to show up and ask questions. And this could be for the workshops or whatnot. or outside, design questions outside of the course also, because I guess you have other courses that you also would like to apply these principles in. Anyway, take up the old notes here maybe. In the first lecture, we talked a little bit about this when to do analysis and design, and basically we used unified process as the framework, and we saw that, well, we do have the opportunity to do both analysis and design throughout the project really, and work with analysis and design whenever we feel the need to do so, and there is no specific phase or specific time when you stop doing analysis and design. However, you may remember the diagram looked something like this, that you can see that the focus of analysis and design is, well, it's towards the start, but it can actually happen here also. And this is something to strive for. What I see in a lot of projects is this, well, you don't implement much to start with, very little, and the deadline approaches and you try to do everything. So that is not a good approach, I think. Okay, I get a question here. Where can I find my username and password for the test exam? It's blank on the actual exam page. I think you need to approve the scripts on the page in your web browser. It's in I can show it. If it's in Chrome, or Firefox, I think it's a little shield icon either on this side or some other side. So I will just make a brief. So here we have a little shield in Firefox, and you click it and you approve the page, and something should be shown here. And you of course need to log in also. Don't forget to log in CoursePress. So, and also throughout the especially when we have done design during this this course, we have sometimes done design to start with and then coded, and sometimes we have had some code and we have seen problems in it and done refactorings and done design in this way instead. And we have also seen that, well, to accommodate this new requirement that has popped up, we need to do some kind of a redesign, and then we have done some refactoring or reverse engineering of code into diagrams, and then seeing that, okay, we can solve this in this way. So it is, especially between the design and code, it's not clearly defined what is what actually. And when you code, you always have some kind of a mental model, at least in your head, of how things are supposed to work. And this model is of course quite limited, because you can't keep stuff in your head for such a long time and not so many things. So just scribbling them down on a piece of paper, that is also doing design work. So design work does not mean that you step away from the computer and make wonky diagrams. And the lines are quite blurred here, when to do design and when to do implementation, and they are quite mixed. It's just like, when am I doing testing and when am I doing implementation? Well, I test during implementation, and I design during implementation, and I implement during design, and I implement during some kind of testing also. I'm only seeing a lock in Firefox, and I can't approve the page. and I can't find the credentials in Chrome, and the exam link doesn't do anything. Have you logged into to CoursePress? Okay, but we can take a look at that during the break instead. So the lines are a little bit blurred, and what you do is very much up to the kind of project you have. If you are a number of developers that needs to be synchronized before starting implementation, well, then you probably need to sit down and sort things out first. So if you just do this project for yourself, the amount of pre-design is, of course, could of course be less. But if it's a big project, well, you probably benefit from sitting down and thinking about stuff in advance a little bit. So, why do we do analysis and design? Well, basically we talked about this semantic gap, and well, the ideas or problems we have as humans are quite different from what the computer actually needs to execute, and it can be hard to make this transformation from idea or problem or requirement into in machine code. So instead we have high-level languages where we can write text in somewhat understandable format instead of hexadecimal or binary. And we have a compiler to make this transformation. But even then the step can be quite large, and we have analysis and design to help us to shrink this shrink this semantic gap we have. So it's supposed to make things easier for you. That is the basic idea. It's supposed to make things easier. And of course, as when you learn a new tool, it doesn't always seem so, because I have my old saw and it works just fine, but this new power saw is well, it's probably good, but it takes too long to learn, so I will stick to my old saw. So this is of course a problem we have in education, but it's supposed to make things easier for you, and if it makes things harder for you, well, you're probably doing it a little bit wrong then, making it too complicated. This is often the case in students, that you tend to make things a little bit too complicated. And this is something that comes with experience, of course. And why object orientation? Well, it supports three fundamental ways of humans understanding the world. We have abstractions, we have encapsulation, and we have hierarchies of different kinds. And these are supported in object orientation in a more transparent way. You can, of course, have procedural development that tries to do these things, of course. But in object orientation, these are a fundamental part of the models that you can do, and of course also of the languages that support object orientation. And the UML, visual language, to make models over different kinds of things, often software. We have been using them for software, but they can be models for many types of different things. And we have focused on of course, class diagrams and interaction diagrams in the form of sequence diagrams throughout this course. But there are other diagrams also in the UML. something that is important to remember is that the UML is well, it's just a language like any other language, and you can use it in any type of process that you would like to use it in. You can do waterfall process, and you can use UML. You can do agile and iterative using UML. So it is not a process. You can't develop according to the UML, but you can use UML to make your projects. And we did this little example, the dice game, where we first did an analysis and then did a sequence diagram where we saw that, well, the player here, he wants to play a game, and where should we put this responsibility? Well, he plays the dice game. So, well, a play operation on a dice game class. Remember also that these are objects that execute. Now this object is anonymous, but it is an object, and you can see that by the colon here and the type name afterwards. And the dice game in turn, well, it rolled the dices it had, and these were named MD1 type dice, MD2 type dice, and it got the values, and it computed a win-lose return value. And the class diagram for this looks something like this then. So we have the dice game class with the association, because it was a member, and the other association for the first dice and the second dice. And, well, the dice had roll and get value operations. So basically this was the introduction, and why we do object orientation, and when we do object orientation, and stuff like that. Should not probably be any questions on this part. The next big thing was actually domain modeling. And we did a workshop on this where you did the boat club, and some of the mistakes in this workshop was that, well, it is very easy to add software concepts into the domain model, especially if you're a developer and you're used to, well, I like to solve problems using software, so I put software in my domain model. But remember that this is the goal of the domain model is to find problems, find improvements, and communicate with stakeholders in the problem area. So, for example, in the boat club, someone from the boat club should be able to understand this model quite easily. Well, boxes and lines are not that hard to grasp, so that should be easy for them. And if you add software, this becomes harder. And especially in this workshop, you had the authentication part, and you had the boat club, and you needed to realize that, well, these are probably two different domains. One is about boat clubs and boats and harbors and stuff like that, and the other one is about authentication. And if you really think about it, the authentication requirements are really only necessary because we decided to do some kind of a multi-user system here. So those requirements are really added because we want to make a software solution for this. And this means that, well, you should probably not focus on authentication. You should not make it too much a part of your boat club domain model. So should not have been focusing on this. And that is also something that is really, really easy to do because it was the first requirement you read. It was also something that you recognized, probably. Oh, logging in, I have been doing that. I've seen that before, and well, it's very easy to focus on stuff that you are familiar with. So that is something to watch out for. So the relationship between requirements and analysis is that the requirements should delimit the analysis, and the analysis should refine the requirements. And requirements are really good. They're good at telling about activities, behavior, rules, actors. So they show what happens or what should happen when certain things happen. So what should this user be able to do? When it does this, this and this should happen. This should be saved, this should be computed, and stuff like that. And the idea of the domain model is not to repeat this. We should not just take the requirements and make them a copy in the domain model. So showing what someone does in the system, well, that is probably best done in the requirements area. However, there is an information need for the requirements to work. The requirements need a certain type of information for them to actually be able to do these computations, to show these things on the screen, to allow the user to do something. And this kind of information is something that we should focus on in the domain model. So what is this information? How is this connected to support the requirements? And this shows a static view over the domain. So how the concepts are related and what kind of information is present in them to support the requirements. Some error that I saw also in this workshop is that, well, you take the actors and you put them in the domain model, and then you say, well, this actor, he can do this and this and this and this, so and it does this on the boat or on the member class. So we draw either a lot of associations to the boat class and says that, well, the member the secretary can delete a member, he can edit a member, or remove a member, or do stuff like that. Or the member can delete a boat and add a boat and edit a boat and stuff like that. However, the idea is rather to say that, well, we need to know that this member owns this boat, so he can do all these things that are already stated in the requirements. So we need to figure out what kind of relationship is supposed to be between a member and his boats, so that we can allow him to do these things that he wants to do. This is the separation of requirements and analysis or domain modeling. So dynamic side on the requirements, focus on stuff that happens, who does what and stuff like that. And the domain model is typically static. So what information do we need to be able to do these things in the requirements? And you should think like a map maker. Try to model the real world. No software. Use the vocabulary that exists in the domain. So typically in the boat club, member is a good type of class, because that is what the boat club handles. They handle members and their boats. And doing some kind of abstraction here, user or person, well, you're starting to kind of like slip away from being specific. Don't include too much information. Remember, this complements the requirements. You're not meant to use the domain model only when doing design, but rather you use both the requirement you're implementing or designing for and the domain model. Don't add things that don't exist. For example, software. Watch out for multiple domains and use the experts that exist here. Checking for nouns, this is probably pretty easy for you to do. And when you have got a lot, well, you need to kind of like remove some. And you can always find duplicates, discuss is this a class or is it an attribute. You have report classes. Is this something that is just a report over something that already exists? For example, a receipt. Is that just a report over a certain sale with the items in this sale? Or is it actually a tangible conceptual class? Something to think about. I think we had the schedule as an example in the course and result administration system that we kind of like had as an exercise. That you can print a schedule. Well, it is a physical entity in reality, but at the same time it's just a report over the courses you're presently taking and their scheduled lectures and exercises. You have description classes, something that can be needed to be added, especially if you have objects, classes that kind of like they share, where objects share a large amount of information, but some things are unique to each object. Maybe a description class can be added to solve this problem. We had the example of cars, I think, where each car had a model and a color, and the model was actually something that was generic for all cars of this model, but the color of the car was, of course, individual. So we made a car description class instead. Actors, something to think about. Is this actors really something that is handled by the system? For example, in the boat club, should the secretary be present in the domain model or not? I can argue for both cases in this case. But you should not just add actors because they can do something. And we also have this issue of different domains. Then we try to find associations. Something that is interesting here is that, well, association is something that should be remembered. So, for example, is it, if the requirements think that it is important that we remember which member that has deleted a boat, then, well, then we probably need an association for this. But if deletion is something that just can be done, well, we don't need an association. So associations denote something that, well, this is something that we need to remember. We need to remember the way that these two objects were connected over some period of time. Verbs can be of use here, but they can also be a source of many associations that are not really necessary. Use good names. This can be really hard. Try to avoid has, contains, or consists of, or generic containment words like this. Try to find out what they actually mean. Not always easy. Add multiplicity when you need to. We have this concept of derived associations also, just like report classes. Well, you can connect things that to make a point that, well, these two are connected, instead of kind of like walking through the other types of associations that does not really make this association as obvious. You can work with association classes, and that is that, well, we need to add some attributes to this association. For example, a time where it is valid is quite common. I think in the boat club, a good use of this is, well, a boat is moored at a berth. But at the same time, we need to remember, well, last year, was it the same berth or was it some other berth? So some kind of booking association class could have been used here. We also have the composition and aggregation, and the idea here is to avoid them. And it's okay to have multiple association and also reflexive associations. So, attributes, well, that's not that hard, I think, so no need to delve into that. History and time intervals is something that is often needed, but not asked for, so watch out for this, especially when you do your real projects later on. You often need to remember information for a longer time than you think, and many things need this kind of history and need to know what has happened with something. For example, a price. We need to know how a price has fluctuated for an item over the item lifespan, so to speak. But it makes things more complicated, so it's always some kind of a balance. But as software developers, it is our job also to find out what the user actually needs. They might not know that they need something, and it's our job to make it clear for them that, well, if we add this, we can have these features. If we don't, well, we can't have them. And we talked a little bit about generalization and specialization, and this is also something that you can find in the domain model in class diagrams, and we saw this maybe in the blackjack game, that we could have realized that, well, the dealer is a kind of player already in the analysis, and this would probably have helped us during the design and implementation. Instead, we got a lot of duplication, and we found out this the hard way, so to speak. So instead of thinking thoroughly in the analysis and having this information when we did the design, we ended up with code duplication in the implementation that needed to be resolved, and we could kind of like work backwards. And sometimes it's not that easy to spot. I think in this case we could have spotted it. We could have seen it, but we didn't. Maybe I also did that to make a point. Who knows? Anyway, we have these two rules to abide for. That is the 100% rule, and it says that all the information and relations should apply in subclasses. So if you make something that is more special, well, all the more general part should apply to this special part also. And in our case, we saw that, well, the player, he has a hand of cards, and this is also something that the dealer has. And we found some functionality and behavior that was the same. And you should be able to say is A. And definitely the dealer is a type of player in blackjack. And we also need to add something, or the subclass is something that is, well, maybe it's not needed at all. So specialization classes, subclasses should add something. This could be an attribute or associations, or something that says that this type of class, objects of this type of class are handled differently in some way. And also something that is important is that in reality no abstractions exist, I think, at least. You can't walk into a store and ask for a fruit and buy a fruit. That is impossible. It won't say this on the receipt, and you won't get the fruit. You will get a banana or an apple or a grape or an orange or whatnot. You will get a specific class, so to speak, the specific object. You can't buy a fruit. So basically that's it for domain modeling. In my opinion, domain modeling is a little bit underused. I think the little time you spend on doing a domain model for your requirements are well spent. especially since they find omissions in the requirements and things that you haven't thought about and need to ask your users. So please do domain modeling. Try to understand the problem before you try to solve it. And this is quite hard because we are quite solution oriented and we want to make the solution really, really quickly, and often we don't understand the problem well enough to make a good solution. So I'm not saying that you should spend days or weeks or months doing analysis, but maybe you should at least spend 2 hours at the start of your project and try to understand things before trying to devise a solution for them. And this becomes especially important in domains that you don't know so much about. And this is something of the both a dilemma and an interesting part of being a software developer is that you need to understand someone else. You need to understand someone else's business. You need to understand someone else's customers and end users. We don't do software for software's sake. We do software to solve problems for someone else. So you need to be an expert often in some other kind of domain. You need to be an expert in insurance, in sales, in warehouse management, in whatnot. Because you are working with customers and users in this domain, and you need to talk their language and you need to understand them. And especially as the role of a developer is now more or less also being very interactive with end users for agile development, this becomes even more important. So your job will be to be expert at software and know what software can do, and also be experts in knowing how to understand your customers and your customer's customer and their problems and how they would like to have things, and show them the opportunities that software can provide for them. And domain modeling is one way of understanding a new problem area. So the next time you are doing a boat club, you know where to start at least. So let's move on a little bit quickly. We talked about software architecture. We talked about these 4 views. Maybe we should just go through the slides a little bit quickly here. And this was more or less to have a starting point. Well, we need to have a starting point when we start our more maybe detailed implementation and design, and we need to know the basic structure of the application. And this is because the low-level design and implementation is often not enough. You run into problems more often than you don't by just going into implementation. And we make a lot of early decisions that can have a large impact on the system we do. For example, well, we decide to make a web-based system. Well, we know how to make web-based systems, so let's do a web-based system. We should do this in PHP and MySQL, and it will be great. But maybe we also have some really, really hard security requirements. And in that context, maybe a web-based system isn't a good choice. So we need to find out these decisions and look at them and try to balance these system qualities that we would like to have. And find out why do we really need a web-based system? Is it because, well, we need to have multiple users, and the web is a common way to get multiple users? Or maybe is it because we need to have some kind of remote access to our system? We have users that are spread out throughout the world or in some places. Or why do we need this web-based system? Can we cope with just a single user application instead? That will be much more secure. We can lock it up in an office. So don't rush into things too rapidly. And this is also the problem when we are too solution-oriented, that we don't really understand why we're doing things. We just kind of like throw a lot of house at problems. So we solve a lot of problems, but we don't really know what kind of problem it is that we are trying to solve. So thinking about software architecture can shed some light on this, these early decisions that we tend to make maybe a little bit too rapidly. And we can think about this in different types of views here. We focused on the logical view. How are we going to structure our software in terms of packages and classes in these packages and the responsibility of these packages. But we can also think about hardware. Servers and hardware and kind of network cables and stuff like that, or dedicated hardware. And we can think about processes like the web server process or the database server process and where these reside. And we can think about how we are going to structure our implementation, what kind of APIs are we going to use, and middleware and stuff like that. So, large-scale organization of classes into packages. We'd like to try to find these groupings, and we'd like to encapsulate further, and we would like to define valid dependencies. And, well, we can use our experience and patterns for this. And we looked at the model view separation principle, and this is something that you have been using for workshop 2, I hope. And basically, you have the user interface and you have the domain and business rules, and you don't want any dependencies from the model to the user interface side, and you don't want any business rules in the view. Questions on software architecture? I will just make a quick run through and we will take a break. So we talked then about the model view controller pattern, and it's a refinement actually of the model view separation principle. So instead of just having a view, we now have a view and a controller. And the idea is that the view handles visualization and low-level input, often quite platform-specific. And the controller is running the show, so to speak. It executes user scenarios. Let's see if we have some kind of overview diagram here, maybe. Yeah. So we have these 3 packages instead. And we can still don't have any dependencies between the model and the view side, so to speak, or the user interface side. So this dependency down here, well, that is illegal. But the controller can depend on the model, and the controller can depend on the view, and the view can depend on the controller, and the view can depend on the model. However, often you decide which way to go here. So when you use the model view controller package, you decide that, well, in our case, the controller should depend on the view, but the view should not depend on the controller. That is illegal. And also we decide that, well, the view can depend on the model, but it can only read data. It can't change data, because we would like the controller to handle all changes of data to execute the scenario. And basically, you need to be disciplined when you do implement this, and it is not always that easy in reality to make these distinctions. In the heat of development, and when the deadline approaches, well, it's just so much more easy to just change the member's name directly in the view, instead of sending some kind of event that the user wants to change the the username and handle this in the controller. So things probably need some kind of a checkup here, so that, well, you tend to add a little bit of erosion, so to speak, to this architecture that you have decided upon. And in the worst case, you just say that, well, we are going to use the model view controller pattern, and then everyone gets a little bit slightly different interpretation of that and does things in a little bit different ways. And we also talked about layers and components. I won't go into that any further, I think. Questions so far? No? Okay, let's do a break. Can we have multiple classes for the controller? Yeah, there can be multiple classes inside of this controller component. There often are. Often there is some kind of a, let's call it a master controller that kind of like dispatches control to controllers for different scenarios, depending on what the user wants to do. This also depends a little bit upon what kind of system it is that you do. If you do a desktop application, well, the application kind of like runs all the time, and you can have the active controller. In a web-based system, well, that's stateless, so then you need to find out the controller that the user is running in for this session or for this command that he wants to do. So, but there are often multiple classes in the controller. So, all right then, let's take 15 minutes of a break, and I will try to sort out the problems with the exam stuff during that.